Okay, good evening, girls. Let's continue. Okay, so we are starting with volume of the gases. We did about the moles calculation and how we can find the moles from if we have the mass or the molar mass given. We also did the concentration in moles per dm cube and in grams per dm cube. So now we are starting with Avogadro's law about volume of the gases. So this law basically states that if we have same conditions of temperature and pressure, two conditions only, we are not going to see other conditions only. If we have same temperature and pressure for two gases, they are going to have equal volume. Okay, they are going to take same volume, same space. What does mean by this? It means if we have 1 mole of the gas, let's say, at standard temperature and pressure, at room temperature and pressure, then that 1 mole of the gas is going to take the space or volume of 24 dm cube. Okay, so 1 mole of any gas is going to be equal to having the volume 24 dm cube only. It is 24 dm cube, not always. It is 24 dm cube only when we have room temperature and pressure. Specific condition. What is room temperature and pressure? Room temperature should be 20 degrees Celsius and pressure should be 1 atm or 1 atmosphere. If we have these two conditions, during these conditions,
Miss,
1 mole of any gas is going to have 24 dm cube volume. Yes.
Miss Nyamba, the room temperature is 40 degrees.
So then we will change this value. Then it will not be 24. If we want 24, then we need the temperature 20 degrees Celsius. Okay. Only at that specific temperature and pressure, 1 mole of any gas will have 24 dm cube. 1 mole of hydrogen, 1 mole of carbon dioxide, whatever gas it is going to have 24 dm cube. Okay. If conditions are changed, then this formula, then this topic, then this Avogadro's law is not applicable. This is clear? So we can take this volume in 24 dm cube as well. We can take this volume in cm cube as well. If we are taking in cm cube, then 1 mole of any gas is going to have the volume 24 thousands of cm cube. Okay, in dm cube it is 24 dm cube and in cm cube it is 24,000 cm cube. Okay, now we can have a formula. So formula is if you want to find the moles of any gas, you don't know how many moles are there. You know 1 mole is 24 dm cube, but how many moles are there? If you want to find the moles, we have one more formula of the moles, and that is mole is equal to volume in dm cube volume of gas in dm cube divided by 24 dm cube. Okay, this 24 dm cube is also known as molar volume of the gas at room temperature and pressure. And room temperature and pressure we can say RTP. RTP means room temperature and pressure, and that is 20 degrees Celsius, 1 atmosphere. And this 24 dm cube volume or 24,000 cm cube volume is known as molar volume of the gas. Okay, so moles are equal to volume, normal volume in dm cube divided by molar volume, which is 24 dm cube. So if you know the volume of anything, you can just divide with 24 and you will get the moles. That's it. No need of the mass, MR or anything. Moles in volume in dm cube divided by 24 dm cube and you will get the moles. Or you can do this in cm cube as well. Moles is equal to, if volume is given in cm cube, let's say, then you can divide this with 24,000 cm cube as well. Like this. Then you can apply this formula and it's the same, just the unit is changed. And you can easily find the moles. Okay. If in some of the questions, they will give you moles and they will give you that this gas is at RTP conditions, room temperature and pressure, and they will ask you to find the volume. How we can find them? Moles are given, RTP condition is given.
Multiply moles
It will be
and
mole
24
multiplied
dm.
by 24.
Right. This 24 will go on the other side and multiply. Moles multiplied by 24 is giving you the volume in dm cube. Or Moles multiplied by 24,000 will give you the volume in cm cube. So same formula we can rearrange and find it. Okay. So this is only the new formula for today. And let's move forward. If we want the same thing, if we want the volume, moles multiplied by molar volume 24,000 cm cube or 24 dm cube. This formula we can rearrange and use. And for the moles, it is volume divided by molar volume. Volume divided by 24 dm cube or 24,000 cm cube. Okay.
Miss, I have a question. Miss, I have a
Yes,
question.
yes, sure.
Miss, so basically we use the volume to find the number of moles. So it's another way to find the number of moles.
Yes,
for
it's
the
another way to find the number of moles. For moles, we have many formulas. Okay, so this is a new formula to find the moles. Okay, so when we can apply, check out this example, work example. What is the volume of 154 grams of nitrogen gas at RDP? Grams of nitrogen is given and we need to find volume. So first of all, what will be the formula that we can use here? Yes, I can show you the formula again, and the formula was this: moles equal to volume over molar volume. Can we rearrange this formula and use here?
Yes.
Because we have RTP. RTP means this formula. Whenever RTP is given in the question, mean this formula we have to apply. Okay, so formula is mole is equal to, they are not asking us that we have to find the volume in cm cube or dm cube. So we can do in both ways. So dm cube is easy, we can do that. Moles is equal to volume in dm cube divided by molar volume 24 dm cube. Okay, 24 will go on other side and multiply.
Miss, I'm confused.
Hmm.
How there's a mass where did the 154 of
Mhm.
grams of nitrogen isn't a mole, neither volume, neither RTP.
Right. So your question is right. Let's see. We have the we want to find the volume and we are provided with mass. Can we use the mass and nitrogen formula to find the moles, first of all?
Yes.
So then use this formula
But
after finding the mole.
volume isn't given to us.
No. Volume we have to find. Molar volume is 24. Okay. Volume we have to find in dm cube. Molar volume is 24 and moles we can find from mass. Right?
Yes. Yeah. Yes.
Okay, so now tell me how you
Find
can find the moles. Moles will
find
be equal
the
to,
AR of nitrogen.
right, AR of nitrogen. So mass over AR is going to be moles. So mass is given to you 154 AR of nitrogen. You can check from the periodic table as well. Otherwise, keep remembering the simple ones. Nitrogen 14. And nitrogen is present in the form of,
Nitrogen is 11.
nitrogen is
11
14
moles.
and it is present in the form of diatomic, two atoms together, N2. Okay, so nitrogen gas is N2. When it is simple nitrogen, it is always N2 because it's a non-metal and we said that non-metals are present in the form of two atoms. So AR is going to be 14 plus 14 or 14 times 2 because two nitrogens are there. Okay, find the moles. Calculate.
It's 5.5.
How do we know if there is two nitrogens or there's
Because
one?
it's a diatomic, it's a non-metal, and non-metals when present in the form of element, they are present in the form of two atoms. Most of the non-metals. Okay.
It's 5.5. How?
5.5. Okay. Now apply it here and tell me the answer. 5.5 moles multiply by 24 dm cube is giving you the volume in dm cube.
132.
132 dm cube is going to be your answer. Okay, you can even find in cm cube, then you have to multiply here with 24,000. Otherwise with 24 and get the answer in dm cube. This is clear to everyone? Any question here?
No, thank you.
Okay.
Is it most of the time, when they ask us, most of the time that the number will be 24. Most of the time, most of the
It's always 24. Whenever
Oh,
in the question RTP word is given, means room temperature and pressure. It means we can apply this formula, moles equal to volume over 20 for DMQ. Okay, it's
Okay.
always. So this
Miss, what if
formula
it's not written?
yeah, this formula is basically a standard formula. It's applicable whenever RTP is given. If RTP is not written, then we cannot apply this formula. Then we are not sure what are the conditions. Okay.
So what will we do?
Then they may give you some other values. They may give you the molar volume. They may give you the volume or moles or mass. Some other conditions will be given.
Okay.
For RTP, we will find volume or maybe the moles, but RTP condition will be given to you. Only then we can apply this formula. Okay. Okay, let's move to another question after that. Okay, let's check out question number 2. This is a straight question and easy question basically. This is another way how the exam can ask you questions. So remember, we did balanced chemical equations, right? Symbol equations, and then we did the balancing of equation as well. And then we said whatever number is written at the start or coefficient is basically telling us the moles. And we can say it as a molar ratio, right? For example, here, C3H8 is just 1. Oxygens are 5 in this equation. So it's 1:5 according to the moles, right? Carbon dioxide is 3, ratio 4. So we can check the ratio of the whole equation. So this is basically the ratio of moles. It is telling us what is the molar ratio. How many moles are there in the balanced equation. Same way, we can also find the ratio between the volume. How? Let's say if they tell you that C3H8 volume is 20 cm cube, okay, then what should be the volume of oxygen? 1:5. If C3H8 has the volume 20, what should be the volume of oxygen? Use the same molar ratio. It means,
Miss Aisha,
yes,
sorry that Miss Noor can't join.
who can join?
Noor Bilal. Sorry for interrupting you.
No problem. Okay, so check it again. If this is going to have the volume 20 cm cube, right? What should be the volume of oxygen? Use the same ratio and multiply this volume with 5 to get the volume of oxygen. Getting this point? Then it will be 20 times 5, 100 cm cube. Same way. Now you will tell me, if I want to find the volume of carbon dioxide, what should be the volume?
20 by 3, which is 60.
Right. And for volume of water?
20 by 4, 80.
20 by 4. Very good. So in other words, we can say if we know the ratio between moles, same is going to be the ratio between volumes. And we can easily find the volume of all others if we know the volume of one of the thing. Maybe reactant, maybe product. Okay. So let's use the same thing over here in this question and try to find out. Okay. So the question is saying that we have the complete combustion of propane gives carbon dioxide and water vapors. Equation is given to you. Volume of oxygen we have to find. Okay. And you have 150 cm cube of propane. C3H8 is propane. 150 cm cube of propane is there. What should be the volume of oxygen? Yes. If this propane is 150 cm cube, what should be the volume of this oxygen according to the molar ratio? Yes, Jana.
150 by 5.
Multiply by 5. How much is the answer? Quickly tell me.
750.
Right, 750 cm cube for the oxygen. Okay, now they're asking one thing more. What is the total volume of all the gaseous products? Products and gases only. So we have 2 gases products, 3 CO2 and 4 H2O. Both are gases. So find the volume.
The reactants, right? So we don't have to find the reactants.
No
Only the
reactants,
product.
yes. If they say total gases, then reactant product. Now they're saying just gaseous products. So find the volume of CO2, H2O, add them together. Yes, what is the volume of CO2?
We multiply 150 by 3,
450.
then we add them.
Right, so 150 times 3 is how much?
450.
450.
Miss, the total
150.
Then
the total is 1,000.
450. Then 4 times 150 is
600.
600. And
600.
total of these two products is
1050.
1050, same unit, cm cube. That's it. So this is the easiest question as well. Here they are just telling you one of the volume and you can easily find the volume of other reactants and products. Okay, yes, Jana.
No, I wanted to answer this one.
Okay, so 1050. So if they ask you to find the volume of any reactant, any product, you can do. If they ask you to find the volume of total reactants and products, you can add them together. Here they're asking just products, we are adding the products only. Okay, so yes, Mariam.
Miss, يعني to get 150, why did we multiply this C3H8 with 5 to get 150?
Because C3H8 is 1 mole, coefficient is 1 here, and oxygens are 5 here. So 1:5. It means whatever is the volume of CH3H8, oxygen is 5 times more. So ratio. So we are going to multiply with 5 to get the volumes of oxygen here. Okay.
And also multiply the 3 with
Yeah,
5.
because CO2 is 3. So multiply this volume with 3. For water, it is 4. Multiply this 150 with 4. Okay. And get the volume. Okay. Let's move forward to the question file now. We are going to start with the Edexcel file, starting from the page number 46 till 63. Okay, so let's start with our question number 1. I hope everyone has the question file with you. We have multiple choice questions, so you have to very carefully solve it. First of all, get the answer, and then we are going to mark it. Okay, understand the question first of all. Question is, a student wanted to make 15 grams of zinc chloride. This is zinc chloride. Wanted to make means something product. ZnCl2 is zinc chloride. Okay. 15 gram mass of this zinc chloride is given to you. What is the mass of zinc carbonate? Zinc carbonate mass, ZnCO3 we need. That is needed to add to the hydrochloric acid to make 15 gram of zinc chloride. So they said, find the mass of this zinc carbonate, and mass of this zinc chloride is given to you, that is 15 grams. That's it. We don't need HCl, we don't need carbon dioxide, water, they are extra for us. We don't need them. Okay, that's it. AR values of carbon, zinc, oxygen, chlorine, hydrogen, all are given to you. So now tell me how we can solve it. What should be the first step?
We will find the moles for zinc chloride,
Right.
and
Then?
then we will compare it to the zinc carbonate, and then we'll find the mass of zinc carbonate.
Very good. We have these ratios. It's a balanced equation. It's 1:1, right? We can easily find the moles of this ZnCl2. First of all, use the moles over here. It will be same because 1:1. Then use these moles and find the mass, right? So you can divide this into two parts first of all. So let's find the moles of ZnCl2. For the moles, what is the formula of the mole?
Moles
over
equal
molecular
mass divided by molecular
Molecular mass, right? So molecular mass of ZnCl2 we need. So just quickly check out, calculate MR of ZnCl2. Okay, Zn. It is over here given to you 65. Then for chlorines, tell me quickly.
35.5, but we multiply by 2 because there is 2.
Right, so total will be
136.
136. Now get the moles. Moles of this ZnCl2. 100, no, moles is mass over molar mass. So you are provided with 15 grams over
15 over 136.
Right. So what is the answer?
It's 0.110294.
Okay, so 0.11 we can take. So,
Miss, it's a very long number.
yeah, so we
So
can just take two, three
1.
numbers. That's okay. Okay, so now what will be the moles of ZnCO3?
0.11.
Same moles because the ratio is 1:1 in the equation. So ZnCO3 in the exam you will be writing this way. MR of ZnCl2, moles of ZnCl2, then moles of ZnCO3 so that everything is clear. So it is going to be same because the ratio is same. All the steps are clear. Okay. Now, find the mass. What is the formula of mass?
Will be moles times molecular mass.
Moles times molecular mass.
Very good. So molecular mass of ZnCO3 we need first of all.
Will be 65 plus 12 plus 16 times 3.
Very good. 65 plus 12 plus 3 times 16 for oxygen. Okay. So final answer is going to be
It will be 125.
125 mR. Okay. So moles time mR. So moles are 0.11.
0.11 times 125, which is 13.75.
13, no. My answer was
13.75. That is approximately 13.8 grams. So you are getting the answer B over here. Right?
They sometimes can round off, like not give you
Yes,
the
yes.
exact.
A little we can round off. 13.75 is 13.8 basically. So that is the only closer answer we have in the options. Okay?
Okay.
So B is going to be our right answer. Okay, then move to the next question. This is clear. Everyone has written it.
Miss, should I ask the number?
Okay. Okay, let's move forward to second question. How many moles are present? Moles we have to find in 9 kg of glucose. Okay, how we can solve this question now? Moles will be equal to
Miss,
Miss,
they already
we
have
will
given us the
convert the
molecular mass and then the molecular mass and the mass. So 9 divided by 180. That's it.
Miss, won't we convert the kg to grams?
Yes, that's very good. It's not 9
Oh.
divided by 180. First of all, we need grams. Okay, we have to convert this kg into grams. So it will be 9. How we can convert to grams?
Multiply by 1000.
1,000.
1000, 9000 grams. Okay, now apply the moles formula. Mass over molar mass. Molar mass by chance is given to you. 180. Easy. No need to
It will
calculate
be-
it. So
it
get
will
the
be
answer.
50
50.
moles.
B is the right answer. 50 moles. Okay. This was easy. Let's move to little hard questions. Question number 3.
Miss, can you go back for the question one
Yes,
second?
yes, sure, I'm going. Some of the questions are not from this topic. They are not coming in your quiz, so we will skip them. Okay?
Miss, is this book Edexcel or Cambridge?
It's the Edexcel file. You
Okay.
can practice for
Miss-
now, then we will move to the Cambridge questions as
Miss,
well.
if I'm
Okay?
Cambridge, should I write this in the notebook or no need?
You can write in the notebook, yes. Write it.
Directly accept. Let's go
Okay.
down.
Okay. Then question number 3, we are not solving for now. The whole question 3, because question 3 is from another chapter that we'll do later. You can go to directly question number 4. 3,
Oh, the whole
3E.
for 3.
3E. Question number 3E is from the same topic. A, B, C, D, you can skip, and 3E. Okay, an organic compound has the percentage composition by mass. Carbon is 36.36%, hydrogen 6.06%, and fluorine 57.58%. Empirical formula is also given to you. You have to prove it as a right empirical formula. That's it. How we can prove
We'll
it
take
as a right formula?
percentage as grams.
Percentages
Miss,
are basically grams.
percentages are actually calculated as mass.
Right? So we can write, first of all, step 1 is write the elements, carbon, hydrogen, and fluorine. As you said, the percentages are basically grams.
Mass. Yeah.
So 36.36 grams, 6.06 grams, and 57.58 grams. All are grams basically. Now, what is the next step? Writing. To find the empirical formula, what is the next step?
Maybe something related to ratio.
Yeah, we are writing AR, then find the moles.
Ah.
Carbon is 12, hydrogen 1, fluorine is 19. You will keep checking them from the periodic table. Now, tell me what are the moles, how we can find them,
Mass over molecular.
No,
right?
AR
So,
over mass.
mass over AR.
Mass over air.
Right, so calculate here and tell me for carbon, it is
3.03.
3.03. Here it will be 6.06 over 1 same. And here 57.58 over 19.
Miss
This
3.03 something something something. So
Okay, you can take till 3 significant figure, 3.03. Now, what is the next step to get the whole number?
Divide by the smallest one, which is 3.03.
3.3.
Right,
Yeah.
divide all with the smallest one.
Miss, they'll all be 1, and this one will be 2 in the middle.
Right,
The
1,
chlorine
2,
1.
carbon is 1, hydrogen is 2, fluorine is going to be 1. So we can say yes, CH2F empirical formula is correct, right?
Correct.
Okay. Now, empirical formula is given to us. We proved it right as well. The second part is relative molecular mass, MR of the compound is 66. Find the molecular formula of this compound. Those who attended yesterday's class, they remember this formula. Can anyone tell me how we can find the molecular formula?
Miss, didn't you like said that yesterday
No problem. You will just see now and you will get it. Okay.
Okay.
Anyone who can tell me, or should I revise this one with you? Anyone can tell me how we can find the molecular formula? Okay. Okay, I can tell here. Molecular formula is going to be, for molecular formula, we basically first of all need a number n. N is empirical formula mass. Sorry, wait. N is molecular formula mass over empirical formula mass. Molecular formula mass divided by, write this with you, empirical formula mass. Okay, right now we have the molecular formula mass MR 66. So we're going to write 66 divided by empirical formula mass. Empirical formula mass means find the MR value of empirical formula only, which is CH2F. So empirical formula mass is going to be carbon is 12, 2 hydrogens.
Miss, here, do you mean N or M?
What? This N number. N
Yeah,
is equal to molecular formula mass over empirical formula mass.
Miss,
So
what does N stands for? N for what?
N is number
Very-
of empirical formulas. So I will tell you why we need this N. Okay. So N is equal to molecular formula mass over empirical formula mass. So 66 is given to you as the molecular formula mass MR. Empirical formula mass means check the mass of empirical formula given to you or you calculated. CH2F. Carbon is 1, 2 are hydrogens, 1 is fluorine, 19. Tell me how much is the total number? Empirical formula mass. 12 plus 2 plus 19 is going to be 33. So this is empirical formula mass. Divide this with 66. You will be getting the number 2. Now,
And then we multiply 2 by the empirical formula.
very good. So this 2 number basically we have to multiply with empirical formula to get the molecular formula. Okay. So the
Why-
next formula that you can write over here, I will tell, just wait. Molecular formula is equal to this number 2, whatever is n you calculated, n multiply by empirical
1.
formula CH2F. Means double the numbers. Carbon is 1, multiply by 2, carbon will become 2. Hydrogen is 2, double it is 4. Fluorine is 1, it will become double, now 2. So this is basically molecular formula. So n is basically the number by which the empirical formula was simplified. Okay. So we said molecular formula is original formula. We can divide them with some number to make it simple empirical formula. But if we want to go back to original formula, then we need that number by which we are dividing. That number is n. And to get that number, we need molecular formula mass over empirical formula mass. You will get that number, and that number you're going to multiply back with the empirical formula to get the molecular formula. Okay, this is clear to everyone?
Yes.
Okay. Now
Miss,
after
I'm
that,
confused. I didn't get it.
again, see, you got empirical formula, right? You want to go to the actual formula which was original without simplification. That was basically C2H4F2. But how we can get this? To get this, we need that number back by which we were dividing this C2H4 to get CH2F. We were cutting this with 2 divided by 2 is 1, 4 divided by 2 is 2, 2 divided by 2 is 1. So we're cutting this or dividing this for 2 number. That number 2 we need. To find that number, we have a formula, and that is check out the mass of original formula, which is molecular formula mass given to you as a 66. Then divide this with the mass of empirical formula. Empirical formula is CH2F, its mass is 33. So we will divide 66 with 33 to get the number 2. Clear?
Yes, Miss. Now I
Yes, yes, Miss.
Okay.
How did you find 33?
33 from the empirical formula. It's the mass of empirical formula. Empirical formula has 1 carbon, 2 hydrogens, 1 fluorine. That is 33. Okay.
Okay, thank you.
You can finish writing and then join the same link again. Okay.